Hello guys, in today's video I wanted to show you how you could create this nice noodles growing setup here. So basically we have a curves that are growing inside of the mesh, and then the mesh basically breaks and noodles grow out. This is effect similar to the man versus machine. They had a project, but of course their version looked a little bit better, but this is the setup that I came up with. And of course, before we start, just wanted to plug in my Boosty page. You could buy a exact scene that you need. For example, this scene, you can buy it directly, or you could subscribe to me for $5 a month and get all the content that I have on my page. But I have this collection of my Gumroad projects. Basically, there is about, I don't know, 18-20 projects, including Gobo packs and stuff. And also you can get my HDAs here. You could also get other scene files that I have on my YouTube channel. And of course, I'm updating this basically twice a month. So twice a month I do a project and I upload this to my Boosty page. So thanks for your support. Let's start off by creating GeoNode, and I'm gonna import my model. So I'm gonna use GLTF file format. I had this model from Polyheaven. Here it is. So I download this in GLTF format and I'm gonna just import this right now. So let's select the path here, and here's the model. Let's use a match size node. So we're gonna just normalize the position and then the size of this model like this, and then we're gonna subdivide this one time. So basically we're gonna select this open subdiv loop because our mesh consists of triangles, and let's turn off the UV visualization here. After the subdividing, we could also recalculate the normals before the subdivision. Next step is to use a RBD material fraction node here. Let's connect this up, and then let's visualize this with the exploded view node here. At this moment, it's all random. I want to have more directed control of this. So I'm gonna go into the settings and I'm gonna disable. I'm gonna have only one level of fracture here. And also I don't want to scatter any points, but I do want to use my own input points here. Let's create a simple line, and then let's have around 6 points here. And if you look at this, it sits exactly in the center of this model. You could also use a match size here just to fit this. But of course, in this case, my model is the same as this line, so I'm not gonna use this. And then the cool part here is you could use something like a point jitter and basically have something different here. And then let's connect this to the extra Voronoi points here. And as you can see now, I have this kind of a fracture. So I like that the face is like separate here. We're gonna get this nice growing effect out of this. And then the last thing in this fracture node, of course, I want to have an edge detail here, and then the settings, something like this, for example. Okay, I kinda like this. Nice fracture here. And of course, for the RBD solver, we need to configure this. So let's use RBD Configure and connect the nodes here. In this node, I want to disable the sleeping here, so I don't want to have any sleeping chunks here. And also I want to enable the constraints here, and I'm gonna set this to soft. And to control these constraints, we're gonna use constraint properties here. Let's connect this up, and then in here again choose the soft constraints, and then here's the settings. Basically, if you used Cinema 4D RBDs, basically they had a follow position and follow rotation option. This is this similar thing. Chunk gets like basically breaks with the force. This constraints will push it back. This is kind of what we want, and you're gonna see this in a minute when we're gonna solve this. Let's create a RBD bullet solver here. Let's connect this up. We don't want any proxy because we don't have any proxy geometry, so we're not gonna connect this. In terms of bullet solver here, we do want to enable actually the ground plane here, and also disable the gravity here. And that's pretty much it for this. And if you hit play, nothing is gonna happen, and the reason is there is no force to actually break this. And the cool thing is that we could just use attribute randomize here, connect this up, and we're gonna randomize the velocity here. Let's switch this to add value, and then let's switch this distribution to direction or orientation. Okay, let's leave it at that. So basically this is the like direct force. It's gonna push our chunks by random velocity, but we also want to have a little bit of a spinning force applied. So we're gonna use another attribute randomize, and we're gonna switch this to W. Basically this is the spin force that RBD bullet solver by default uses. This is a 4th dimension vector, so switch this up, and also I'm gonna scale up the global scale here. Let's hit play, and as you can see, basically it breaks and then it pushes backwards, so it has a resistance force in a way. And if you just turn these constraints off here, as you can see, it's gonna just go like that. So to prevent this, we're gonna use this soft constraint, and you can have this a little bit higher, then it's gonna break less, of course. And then the cool thing is that you can just change the seed and it will get different results here. And also you can change the seed for the spin force, of course. Let's set this to something like this, and this is basically what I had. So I had a simulation like this. I like the face that push outwards, and this is something that I'm gonna use. So we did set up our RBD simulation here. What I want to have is I want to this model not break in the first 15 frames. Basically this will be dependent on how much of the inside of the model you want to be grown with the noodles here. So more time you take, more noodles will grow inside of this mesh. We're gonna do that using a retime node here. We're gonna set this to post extend, and the first value is basically your actually not like this, but we want to remove by pressing Ctrl Shift this expression here, and then I'm gonna have 125 frames, and first 50 frames will be static, then it's gonna explode. And then what we want to do from frame 50 to frame 100, for example, we want to slow down this model. You could do this using a simple keyframes, but I'm gonna do this using simple expression here. I'm gonna just say $F here, and I'm gonna use my output range. So I'm gonna just copy this and paste relative reference. I'm gonna copy this again, and I'm just gonna multiply this by 2. So basically I'm gonna go from 50 to 100 because I'm multiplying this by 2, and then I'm gonna have initial speed of 0.15, and then by the end of this it's gonna have a speed of 0.05. Here's the expression. You can look at this like that, and then if you hit play, you're gonna get something like this. Let's unpack this geometry, and what we want to do is we want to delete the inside of this geometry. So let's just use a blast node and delete the inside. And then this is basically will be your geometry render. So you can create a null and call this, for example, out geo, and then Ctrl C, and in here just create new geometry node, and this will be your render geometry here. Let's create object merge and let's paste this here. And this is basically will be your statue for the render. Let's go back inside and let's just select this hide other objects, so you don't want to see this. And we're gonna start from here again, or you could start from here, for example, from this null. Let's use a time shift node, so I wanna time shift this to frame 1, and we're gonna use a bound node here. So we're just gonna create a bound around this object, and if you use a facet node, you can separate these polygons and then use delete small parts, and then let's choose some value here. So as you can see, now we're deleting a top and bottom face here, and then if you invert the result, you can get top and bottom pieces like this. Let's use the extract centroid node. We're gonna set this to primitives, and you're gonna get this 2 points here. And then if you use an add node, you can connect these 2 points to create a curve here. Next up, let's use a curve node. I had parameters like this, and I'm gonna just try to basically fit this to our mesh. You can do this fully procedurally, so it avoids the walls of your mesh, but this is kind of would be overkill for this setup. Let's use a resample node, and this resample node controls the amount of curves you will have in your setup. And let's use orientation along curve node to create correct orientations. We're gonna copy a circles to this curve. Let's use a circle node. Let's switch this to polygon. We're gonna adjust the scale here, and I'm gonna also use adjust the divisions. And as you can see, you get something like this. I just want to have a little bit of randomization here. I'm gonna use attribute randomize, and I'm gonna randomize the normal here. I'm gonna use add value, direction or orientation, and I'm gonna tick these two options here, and the direction attribute would be normal. And as you can see, you get this nice cone like adjustment here. You can adjust this how you want. And also what I had is I used a transform from centroid node, and I just moved this a little bit. So this was my settings here. Something like this. This is basically what I had in my setup. After this, what we want to do is we want to open our curve up. We're gonna use this. For this, we're gonna use ends node, and we want to unroll this with shared points here. Let's also use a connectivity node to give it a class attribute, and I'm gonna use attribute adjust color here. We want to remap the attribute. In our case, it's a class. And then if you hit compute range here, you can see this is a 4, but the cool thing is that you can just reference this segments value here to here, and then also select specific values and reference this value in number of colors as well. And then you can choose whatever colors you want. I'm gonna just choose random colors here. And as you can see, we got this kind of a problem because what we want to do is we want to have this number of segments plus 1, because this starts from 1, 2, 3, 4, but our class attribute starts from 0, so that's why we're gonna just offset this one time. And then the first color I'm gonna just actually the last color I'm gonna choose just a black color. And yeah, this is pretty much our source. Let's connect the pop network here, and let's call this Noodles Sim. Inside of the pop sim, we just want to delete the pop source here, and I'm going to use this as a initial geometry here. So we're going to use our and the expression to get the geometry from the first input. We're gonna get our geometry. Also in this setup, in this scene, I used a ground plane because I had a ground plane in my scene. And let's hide this from the viewport here. And what I want to do is you want to set scale here. So set a p scale, and this is simple. P scale at p scale equals channel float p scale. And in my case, it was 0.01. And what I used is I used gas particle separate node to basically mimic the collision between the points of the curve. What I did was to have more smooth effect. I just update amount, I just lowered this down. I turned this as assume uniform radius for faster calculations. And then distance scale should be set to 2. If you hit play, you're gonna get something like this. It's just gonna basically push points apart and just settle down, because right now we're not doing any resampling here, but we want to do exactly that. So let's create a sub solver here. Let's rename this to resample and collision. Let's connect this and dive inside. In here, first thing that you want to do is use a resample node, and this resample node should be reference to this p scale that we did here. So this would be your controller. So let's reference that. And then the thing with the resample is that it actually opens your curve up. As you can see, you already have something that is growing here, but it actually opens your curve. We don't want that, so we're gonna use a polypath node, and I'll just rebuild curve each frame. And you need to select this connect endpoints. And right now, it's just fine. Also, we need to somehow solve the collisions with our mesh. our collision mesh, we're gonna use object merge, and again we're gonna use our old handy op input path expression. We wanna look twice up, so up on this node and up on this node, and wanna get the second input here. So we're just gonna say 0, 1, so 1 is the second one, and close this. And if you visualize, as you can see, you get our mesh and it's animated as well. And a cool part here is we're gonna use detangle node here. Detangle node is node that is used basically inside of the vellum solver. In this case, we're gonna use this in our advantage. We're gonna disable the self collision here, so we don't want to have our particle self collide because we're already solving this with this gas separate node here. But what we do want to have is we want to have this collision geometry here. And then the cool part here is you want to calculate the rest position after you solve this. And this node, you will use this rest position basically kind of like a previous frame. So we're gonna pipe this rest here. And if you look, as you can see, you already have some sort of a collision here, as you can see. But of course the particle, basically we don't want the ground plane by the way, so let's select the dot network here and let's just use pop star. So we're just gonna import this pop object back. And of course, as you can see, you have the distance between the particle collisions is too much, so we're gonna just lower down this default thickness here, and that should be. And as you can see, these are growing nicely, and this is exactly what we want. What I also want, I want to blur this a little bit, so I'm gonna use a blur. I'm gonna uncheck the pin border points, and I'm gonna lower down the step size, so I'm gonna have a little bit less blur here. And as you can see, you get something like this. It's kind of really smooth, but we're gonna solve this by using a little bit of girl noise here. So let's create a pop-up. All right, let's dive inside and let's take our position and just actually now let's take our velocity and let's add a curl noise to our velocity. So we're gonna sample this from our current position. We're gonna use multiply constant and we're gonna just change the frequency of this noise with this multiply. And in my case, I just adjusted the offset here, so you can play around with different types of noise and stuff like that. So let's connect this up and then plug this into the force here. And as you can see already, you're getting something, but that's actually too much. So we're gonna use a pop drag. We're gonna have a little bit of resistance of this pop force that we did. And also inside of this pop solver, you just want to increase the substeps here. So that's still too much. Let's adjust the amplitude of this curl noise. And as you can see, you're getting something like this, which is pretty cool. So it's filling this mesh, and then as it breaks, you're gonna get this really nice effect. As you can see, the noodles come out, and this can be used on any mesh that you want. So there is like not really much difference. You can use this on whatever mesh you want. Let's convert these noodles to a mesh. So let's use a clean node. We're gonna disable everything, but we're gonna enable remove attributes and groups, and we're gonna just keep p-scale and color here. And then you can use a file cache, and then you can cache this out. I'm not gonna do this, but I recommend you to do so if you plan to render this stuff. Let's use attribute adjust float. Actually, you can just use a sweep node directly. So let's use a sweep. Let's set this to round tube. And then you want to set this radius to 1 and then turn off the stretch around turns here. You're gonna get something like this. In my case, I just set this to 0.5. This was my size. And then you can use subdivide before the sweep to smoothen out your geometry. As you can see, it looks really kind of nice. You can get a lot of different results here, which is pretty cool. Okay. You can also turn on this compute UVs here, and then what you want to do, you will get something like this. But because we're normalizing this each frame and our lengths between those points are changing, this normalized computed UVs use are not gonna work for us because it's gonna change UVs each frame. So you just want to disable this, and then just drop down the UV transform here, and let's just adjust this scale, just increase this, and it will have just absolute UV value, so it's not going to be relative to your curve length here. This is exactly what you need. And then you can have another null. Let's call this out noodles. Let's Ctrl C this. Let's go back. Let's use object merge. Merge this in. And let's call this MDR noodles. Let's create a camera. So gonna just reset everything. Let's go to the camera and let's just adjust the view here. Something like this, and maybe increase the focal length. And let's just do a flipbook. And basically I had a simulation similar to this one, of course. Be aware that this simulation is totally dependent on many factors, such as the initial placement of your curves. The big factor as well is the p-scale. So the less p-scale, the more of those creases here, right, you're gonna get. So if you lower down this, for example, to 0.05, as you can see, you have a lot more detailed curve here. Also, the big part, of course, is this curl noise here. You can turn this off if you want. Inside of this, you can adjust this step size. As I said, there's nothing to adjust in detangle, but you can also you can put here any force, any custom force that you want. So yeah, that's pretty much the setup, guys. So play around with this. If you create something cool with this, be sure to tag me on Instagram or link your video in the YouTube. So yeah, guys, thank you so much. And as I said, if you want to have access to the final scene file with all the lights, materials and stuff like that, just head over my Boosty and you can purchase this exact post, or you can basically subscribe and get everything that I have on here.